Hello everyone, my name is Zubair Altaf Qureshi. I welcome you to my YouTube channel Z Network Lessons, and also I welcome you to this course of Cisco ASA Zero to Hero. And this lesson will be in continuation with my last lesson, which covered the transparent firewall. So I had to cover a few more things in the transparent firewall section. So that's why I'm doing this course lesson. Sorry. So now what we went through in the last lesson was that we now know that we can place the ASA in a mode called L2 or transparent, wherein you don't need to change the IP address schema of your network, and you can still be running your routing protocols and just with the edge and the distribution or whatever your type of design is, and the routing will not be affected by placing a firewall into your network in an inline mode, or you can say an L2 mode. So that is how it is, and we came to know about the ACLs, right? They are working perfectly fine. Now today what I want to talk about is a type of ACL called EtherType. And for those who don't know about EtherType, it's an ACL, but it's an L2 ACL. You can just, understand like that. Okay, let me clear this again. So to understand the EtherType ACL, you need to go a little bit back to the basics, and the basics would be your TCP IP model. So in the TCP IP model, what you have at the top is the application layer, right? So you have the app layer, and then you have the transport layer. Yeah, and then after the transport you have which layer? You have the network layer. That's right, network layer. And then after the network layer you have again layer 2, which is called the data layer. And then at the last you have the physical layer. So now just imagine every layer encapsulates and de-encapsulates, right? There is encap and de-encapsulation on every layer. Yeah, de-encap. So when the packet is moving upwards, it's encapsulation. When the packet is received, it's de-encapsulated. So how, my question is, how do the data layer knows where, what type of, protocol I have to send it to the network layer? Or how does network layer know which transport layer I need to send it to? How does transport layer know which application I need to forward this, packet to? So each layer has their own header, and each header has that special information which tells the transport layer to which application it needs to send the packet to. So for the transport layer, you have a field called port numbers, right, which tells the transport layer where, to which application you need to forward this to. So for example, port 80, it will be sent to HTTP. Port 53, application DNS, like that. 23, telnet. 22, SSH. So that is the thing at transport layer. So now at network layer, what is the thing that tells the network layer to send to which of the transport layer, right? At the transport layer, you have mostly two protocols residing. You have the TCP and the IP. Oh, I just said the word, and you might have figured it out. So in the IP header, you have a field called protocol, and that protocol will decide to which transport layer I have to send the packet to. Mostly you have TCP and IP. So back of the head, if I remember, TCP is protocol number 6 and UDP is protocol number 70. So this is not IP, this is UDP. If that is wrong, please correct it. Check it, and then from the data, how the data layer knows to which network layer I have to send it to. In the data layer, you have the MAC layer and the logical LLC layer and logical unit. So there in the header, you have a field called EtherType. But mostly nowadays you have the, you had many type of IP protocols, protocols rising on network. one was IP, then you had Apple Talk, you have, I mean, more of that. If you go to a document from Cisco, this is the document. If you see here, you can see we have these non-IP traffics, IPX, BPDUs, MPLS, and all those stuff. So to control those traffic, um, you have to use the EtherType. So for example, the BPDUs, right? The BPDUs are allowed by default on in an L2 firewall, but CDP is blocked. CDP blocked. Okay, so we will just allow CDP using the EtherType ACL, and we'll check on R1 and R2. Likewise, you can allow MPLS, and also, I mean, by default the IP, which is 0x0800, is allowed for your information. You can see, you must have seen yesterday, right? We were able to communicate between R1 and R2 using IP. So that is by default allowed. So we will see how we can use EtherType to allow CDP, and that's how we will confirm, right, that EtherType is working. So also, if you configure MPLS, yeah, I'll also show you how to configure MPLS. But then the control traffic is using UDP port 646, which should be allowed using IP access list, right? Not the layer 2, the L3 access list. So we will check that as well. But the data traffic, which can be, I mean, controlled using the EtherType, which is 0x8847. Yeah, I will also allow that, but due to the reason that I don't have an MPLS infra here, I cannot check the data. Anyways, I will clear this drawing, and let's move on to the devices. Let's clear this. Let's close this. So let's go to ASA. ASA is as is. So ASA is already open. Let's go to R1 and R2. I need only R1 and R2. So as I left the configurations, which I did in the last video, the transparent firewall video. So the configuration should be there. If I check show run access list, access list, I can see that I have the TCP telnet is allowed, ICMP is allowed from R1 to R2, and then the RIP is allowed. Then on the outside, I have also, I don't know why I have this on the outside. I don't need this because I already have one here with the specific host from R1 to R2. So if I go to R1 and try and ping, okay, try and ping R2, this should work. Ping 192.1.10.2. This should be working, yeah, because my ACL is configured correctly. And also from inside, I have the RIP, and then I have TCP and ICMP from the inside. And also I actually should do an any from inside. That is better, because all of the traffic would be denied because of this one and at the end, right? So let me do this. I'll say no, and I'll say no to this, and I'll say access list permit. Okay, sorry, inside. Sorry, permit access list inside. It should be a caps access list inside permit IP any. Yeah, so that should be working now. And if I go here and check here, show IP route RIP, right? So I should have the RIP routes, yeah. But I should be able to go from now 192.1.10.1 because I have the IP any there. Yeah. So that is one thing that I wanted to show you. The second thing is, if you check show CDP here on R2, you will not be seeing anything from R1, sorry. But in case of R2, you should see R3 but not R1. Yeah, you see R3, okay, but not R1. So why is it that? Because of the ASA blocking the CDP there. So let me go there and say, so how do you configure this? So you have, remember the rule of ACL. So you can configure one ACL per interface. Okay, and one ACL per interface, I mean, and per direction. One ACL per interface per direction, and then so for example, I have an ACL on the outside, which is called out, and I have another ACL on the inside, which is called inside. Yeah. Okay, inside. Then I can have another ACL on the inside, which will be in the direction of outside. That is also possible. So if I go here on the AC and I say ACL, sorry, access list in, out, in, out, yeah, permit any, so permit IP any, and then I go and say access list in, out, permit, sorry, then I have to apply this, right? Access group in, out, in, interface, inside. So this is the direction, right? So out, interface, inside. I can do this. But if I do the same thing with the in command, it will not take it because I already have one there. Or it does overtake. Okay, so if I check show run access list, if is okay, so it will overwrite now. Yeah, you can see in, out. Now if I check the access group, that should tell me the, so in, out has taken the preference because it has overwritten. So I don't want this to. So one ACL per direction per interface, right? That is the logic. But because this is L3 ACL, so you have separate rule for L2. So you can have an L3 ACL as well as an L2 ACL, but the rule is same: one ACL per interface per direction, whether it's L2 and L3. So you can have both L2 as well as L3 at the same time. So instead of this, I need to say access group inside, in, interface, inside. Yeah, that is fine. So that's what I wanted. Now that's done, said and done. Now let's go and configure the EtherType ACL. So ACLs, let's say CDP. Then you have to specify the EtherType, and then you have to say permit, and then the EtherType. So if you are going for CDP, this is the EtherType. You can search. Then you have to say access group, CDP. No, access group. Yeah, CDP in, interface, outside, and also in, interface, inside. So let's go on R2 and R1 to check the, on R1 I want to check these show CDP neighbors. You have to wait for a while before this will reflect, so let's keep it like that. And okay, and one more thing that I want to show you is the MPLS. So if I go here config t and say MPLS IP, and on the interface G00 I say MPLS IP, and likewise I go here and say config t MPLS IP, and also in the interface G00 I say MPLS IP, and I see the show MPLS LDP neighbors. There will be no neighbor, it should not be there. Okay, I think there is some. Okay, neighbor is up, but I don't know why it's up. It should not be up because I don't have any access list on the AC show run access list. If you check, I don't have any access list that permits. Okay, I already have the access list. Okay, sorry, my bad. It's an old configuration that should not be there. Let's do it again. The neighbor should go down in a while. Config T. If I say no MPLS IP, the neighborship went down. MPLS IP, and now again up. I don't know why. Did I say no? No access list for the TCP? To which I said. Let me check. Yeah, this is gone, right? And then why it's still there? So run access list. Now I see that I don't have this ACL here, but still my MPLS is okay. And let's do a logging enable, logging console 7, logging on. Let's do some t-shoot. Okay, so I want to check the MPLS. Do show MPLS. Do show MPLS. MPLS. Sorry, neighbors. Sorry, LDP neighbors. It's still there. I'll go and say no MPLS, no MPLS IP, interface G00, no MPLS IP. On R1 as well, I'll go and say no MPLS IP, no MPLS IP, exit, no MPLS IP. Oh, that should take care. Show MPLS CDP name. Oh no, sorry, LDP neighbors. So this should not be there now. Yeah, correct. And if I go to ASA, so I see inside outside that has been teared down. TCP 646, yeah, that has been teared down. And I go, maybe the connection was there, so that was the reason that it was yeah, clear connection all. Let's do this. So that is the reason that the LDP was again working. Okay, fine, great. Now let's go here and say MPLS IP and exit MPLS IP. I have to do the reverse, right? Interface first globally, then in the interface. Interface 0 by 0 MPLS IP, and on R1 the same thing. I'm on which ASA. I want to go to R1 config T MPLS IP interface gigabit 0 by 0 MPLS IP. Yeah, and now if I see show MPLS LDP neighbors, that should not be there. And if I go to ASA, this is the correct behavior, because I should see this getting dropped, the 646 UDP packet from outside. You can see. So in order to allow this, you need an ACL. So access list. You can just check this ACL, and you can create an ACL based on this. So let me just go and open a notepad and paste this particular line there. Okay, so I have this one. I'll paste it here. So what I need, so I'm denying UDP source outside to inside. So what I need is, I need to allow this. So how do I write this? Access list out. So I need to allow this on the outside interface, because it's getting denied on the outside interface. Access is out. Then I say permit. Then what is the protocol? UDP, and then I have the host, which is 192.1.10.1, which is getting denied, to host 224.0.0.2, because this is the multicast, and multicast is not allowed by default. So that is the actual access list that I need on the ASA to allow this MPLS neighborship to happen. And I've already applied this on the group, so no issues there. Still, I'm denying this, is it? I think there is some issue with the ACL. Access is out, permit UDP host. Oh, sorry. Access list. Access list. Yeah, access it out permit UDP to host this from host this equivalent this. It's fine. Yeah. So if I say 646, right? This is the one. Executed. Yeah, this is fine because I can see the LLDP neighbors are up now. Now, if I do show MPLS, LDP neighbors, it should be there. So this was the actual way it should be, because the connections it was getting, the packets were getting traversed through the firewall. But by default, this should not be happening because MPLS again is multicast, traffic, which will be denied by default on the ASA. Okay, so that is one thing. Now let's check the show CDP neighbors, which we allowed a while ago. And now you can see from R1, I can see R2. Yeah, because from R1 and from R2, I should see both of them, right? R1 and R2 show CDP neighbors. Yeah, so I have, okay, I have only one right now. Yeah, I have only one. So it might take some time. And okay, did I allow this on the inside? No, right? Show on the AC. Okay, let's go here. Show run access list. I need the EtherType ACLs. So where are the EtherType ACLs? This is the one. Permit, and I have not applied this anywhere. Did I? Yeah, I have to apply this access group out in interface. I did apply this, I think. Let me go and check on the show run access group. And I don't think I've applied this. Okay, I've applied this on the outside as well as inside. Yeah. So this should be working now because R1 is fine. What about R2? R2 will take some time and it will eventually come up. No issues. Because R1 can see now this switch. Yeah. So this is a router which has a switching capability as well, and I means IGMP is enabled. So you can go there and you can see detail. Sorry, detail. Now, if so, you can see this is an L2. So I can see the switch. Okay, I can see the switch on the other side. Yeah, eventually the firewall, the routers will also come up. I can see this switch here. So this R1 can look through the firewall and see the switch using C. So that is there. Now one more thing. So now you know how to create the access list, which is type of EtherType, right? So for if you want to allow the MPLS, then the EtherType that would be like access list, say MPLS, and you say type of the type of ACL is EtherType, say permit, and then the EtherType of MPLS, which is this one. You hit on this, and then you say on the access group MPLS in interface outside. So this is how you do for the MPLS. Yeah. So hope you understood the whole concept of this EtherType. It's nothing but an ACL at layer 2, and yeah. So by default, your MAC address, the broadcast and all those are broadcast MAC address, and the multicast MAC address are by default allowed on the ASA, and the VP, that's how the VPDs will pass through, and the CDP is not allowed by default, so you have to allow and only the IP, which is 0x0800 is allowed, but not MPLS. So you have to go and manually allow the MPLS using the EtherType ACL. So that was it for this video, and please do subscribe to my channel and share my channel as much as possible. Stay connected for more videos related to Cisco ASA. Thank you for now. Bye bye.